All right, lesson 2.7b, derivative of exponential functions. All right, so what is the derivative dx of e to the x? What is that? The derivative of e to the x, that's the question. So let f of x equal e to the x. Just like we did the proof for sine, we're gonna use the limit definition to find the proof of what is, or prove what e to the x derivative is. Let's go ahead and do that. We are using, it becomes so repetitive after a while, f prime at x is lim h approaches 0, f of x plus h minus f of x over h. There. All right, let's go ahead and do that. So the limit as h approaches 0, okay, of this f of x plus h, f of x plus a, x plus h for every x. All right, so for this x, we're going to plug in x plus h. So this is going to be e to the x plus h, okay, and then we're going to subtract f of x, where f of x is e to the x over h. All right, so we're there. So we're gonna now do lim h approaches 0. E to the x plus h can be separated. Just quickly, this makes sense to you, I hope. What is e to the x plus h? If you think about plugging in, say, numbers, and you have e to the 5, let's go e to the 5. E to the 5 would also be the same as e to the 3 times e to the second. So when you separate the bases, you add the powers. So really, so that's what it is, like that, or something like that. So what we're gonna do here is that e to the x plus h is the same as e to the x times e to the h. Yeah, it's just the properties, no? Minus e to the x over h. So yeah, this is fine. So now we're going to continue on, and you see that you got two terms here, but they both have an e to the x, and that's what I'm going to do. I'm going to factor out e to the x. So we got lim h approaches 0, e to the x, factor it out, and now we got e to the h minus 1 over h. So we got the limit as h approaches 0, so it's just dealing with h. So now e to the x becomes almost like a constant again that we can factor out of the limit. So then we have e to the x times lim h approaches 0 of e to the h minus 1 over h. So now, how can we figure out what this limit is? Is there a property we can use? Is there any? The only way I see doing it is by making a table of values and find what does it approach, like when we started the year, about finding what is the limit of something by making a table of values. So if we can make a table of values to figure out what this is, then maybe we can figure out what the derivative of e to the x is. So that's what we're going to do now. So here it's all done. So f prime of x is equal to limit as h approaches 0, and that's just the limit definition. We substitute in, we factored out, and we're at this point right here. We can even factor out the e to the x more here, no? So now this is where we're stuck, and we're gonna do a table here. As h gets closer and closer to 0, let's make a table. So we're looking at this. We want h to approach 0. So let's do h is what? Let's h be 0.01, 0.1. Let's do h be 0.1. and then get it closer to 0. 0.01. So if we plug this into a calculator where h is 0.1, and then we e to the 0.1, and then h is 0.1, this is 0.1, no? E to the 0.1 minus 1 over h is 0.1. You put this in a calculator, and then that gives you back what I just got here. You can verify by using this calculator. It gives you that. And if you use 0.01, put that in a calculator, put it into the function for every h, and evaluate it, it's going to give you this number. If you use 0.001, it's going to give you this number. And the closer h gets to 0, the closer this gets to 1. So 0.0001, it will get to 1. It basically, the closer it gets to h gets to 0, the more it approaches 1. So we can say that this limit is equal to 1. So if this limit is equal to 1, then we have 1 times e to the x. Then the derivative of e to the x becomes e to the x. And so therefore the derivative of e to the x is e to the x. So the answer is itself. So the function e to the x is changing according to it's just itself to whatever the output is. In addition to ddx of e to the u will be e to the u, and then take the derivative of u times du dx, or you could say just e to the u times u prime. You can say that. So you have to take, it's like a chain rule. You don't know what chain rule is. We'll see that in next chapter. U prime times e to the u. All right, let's put this into practice. What would be the derivative of e to the 2x plus 4? Well, it's just going to be itself. Okay, so it's going to be e to the 2x plus 4, and then you take the derivative of this power 2x plus 4. The derivative of 2x plus 4 is just 2, and just put it in the front, and you're done. That's the derivative. Okay, the derivative of e to the x squared, you'll be e to the x squared, and then take the derivative of x squared, which is 2x, put it in the front. The derivative of e to the x over 3, again, is e to the x over 3. Take the derivative of this, which is 1/3, put it in the front. What happened there? Let f of x equal this. Find f prime of x. Well, let's take f prime of x is going to equal to e to the x. The derivative of x is 1 minus 1. The derivative of x is 1. There it is. Okay, now let's find the derivative of this. Well, this is a little more difficult. We can't really use the derivative definition of it, because it just doesn't seem to be it. So we're just gonna have to do some algebra here. So what we're gonna do is we're gonna go f prime of x is gonna equal to, well, first let's separate. Let's do algebra first. F of x is gonna equal to, let's divide this and divide this. Let's separate them. So third root of x will become x to the 1/3 being divided by x, and then you got minus 2x e to the x divided by x. Sometimes you gotta do tricks here. So then, even before, this is all algebra, before we even do anything of that, you got x, this bottom part, you can, to the power of 1, which is 3 over 3 is 1, and now we can just subtract. So this would be x to the, what's 1/3 minus 3/3? That's negative 2/3. All right, we're there. Minus, you can cancel the x with the x here, so it's minus 2 e to the x. And now we can take the derivative. So let's go ahead and do f prime of x. F prime of x will be power rule, minus 2/3, x to the minus 3 over 3, that's going to be minus 5/3, x to the minus 5/3, and then this is going to be minus 2 e to the x, minus 2, and then e to the x is e to the x derivative. We can clean it up a little bit more here and be minus 2/3 and just put it to the bottom. So x to the 5/3 without the negative power, minus 2 e to the x. That should be good. But even more so, we put it in radical form and just say that the derivative of the function is negative 2/3, and then have a cube root of x to the 5th minus 2 e to the x. When you're taking that AP test, you could see this as a possible answer, this as a possible answer, and they're all different forms of the same thing. Let's see. I think that's it. That is what I had. All right, good.